I'm going to run through answers to review for quiz 11. Get you ready to go for tomorrow's quiz. First one, we have a definite integral, so we want to integrate and plug in using the fundamental theorem of calculus. So if I integrate, I'm going to get t cubed minus t, and I'm going from 2 to x. Some of you in class were getting hung up on the fact that this is an x. Don't let that happen to you. All you have to do is plug it in. So I plug in x cubed minus x, minus, plug in 2, so that's going to be 8 minus 2. I end up with x cubed minus x minus 6. There's my answer. Nothing to it. Pretty straightforward. On this one, which of the following is an antiderivative of this? So that just means I want to integrate this. So if I integrate secant squared, I get tangent. If I integrate 2, I get 2x. 3 tangent plus 2x. Simple as that. Number 3. The function f is continuous on the closed interval from 1 to 7 if 1 to 7 is 42 and 3, I can't see it, 3 to 7 is negative 32, then what is 1 to 3 with a 2 in front of it? So in order to get 1 to 3 of f of x, when I put two integrals together, the bottom left number of the first one needs to be that, and the top of the second one needs to be that. So right here I have 1 to 7. Okay, so I've got the 1 that I want. So that means my second one needs to have a 3 up there, since this has a 3. Okay, and since this has a 7, that means this also has to have a 7. So all I have to do is switch those two, which gives me that. Alright, so it says 1 to 7. 1 to 7 is 42. So that means that's 42. This says 3 to 7 is negative 32. So that means 7 to 3 has to be a positive 32. I put those two together, and that gives me 74. But that's just f of x. Now I have to take care of the 2. So I multiply this by 2, and I end up with the 148. Alright, next one. The graph of the differentiable function f is shown in the figure. Let h be defined by this. So h equals the integral from 0 to x of f of t dt. Which of the following correctly orders these three items? So, if I'm integrating f and I get h, then that means f is the same thing as h prime. So f is the same thing as h prime. Because if I integrate h prime, I'm going to get h. Well, here I integrated f and I got h. So if I integrate h prime and get h, and I integrate f and get h, then that means f and h have to be the same thing. So my graph of f down here is the same thing as the graph of h prime. So h prime of 2 is 0. So I know h prime of 2 is equal to 0. So that means h prime has to be in the middle. So it's in the middle here, and it's in the middle here. So that means these three are not possibilities. Now, there's two different ways I can figure out the other ones. If I'm looking at the graph of h prime, then to determine what h double prime of 2 is, I just need to look and determine whether or not it's increasing or decreasing here. In this case, if you notice, we are decreasing, so that means h double prime of 2 is negative. So that means this one has to come first, so that means my answer has to be E. Now, there is a way that means that h has to be positive. So there is a way to determine that h is positive. And hopefully I've ingrained in you that if I have a definite integral one of the things this represents is the area under the curve. Okay, so we're interested in the area under the curve from 0 to 2. If I look at this, I have 0 to 2 right here, and if you notice, this area is above the x-axis, which means this area is positive, which means h of 2 is positive, and that's why it's over here. So a couple different ways there. I always like to start out with the 0. That eliminates some choices, and then from there you've got two options to figure out whether or not something is positive or negative. Number 5. We talked about number 5 in class, I think. No, we didn't. We talked about one similar to this on the homework. So right here, key word here is average velocity. Average velocity. So that means I need to end up with something that has units of... Do I have units here? No, I don't have units. But I need something with a distance over time. So I need a distance over time. Since I'm doing average, I definitely know I've got to do 8 minus 2, which gives me 6. So I definitely know the bottom has to be 6. So that one's gone because the bottom doesn't have a 6. This has a 6, that has a 6, that has a 6, and that has a 6. So those are good to go. Now, since I did 8 minus 2 on the bottom, then that means I've got a time unit on the bottom. So I know all of these have a time unit on the bottom. So I need to know which one of these is going to give me a distance on the top. So if I integrate acceleration, that gives me velocity. Velocity is not going to give me a distance on the top, so that one is no good. When I integrate position, that's going to give me something above position, which definitely is not going to be a distance, so that's no good. Here, I am subtracting position. If I'm subtracting position, that's going to give me a distance. So it gives me C. I know that's going to be my answer, but I'll continue on. This one right here is going to be the same thing as this, because if I integrate acceleration, I get velocity. So v of 8 minus v of 2, which is here, I have velocity over time, not what I want. This is my answer. Now, that's one way to think about this problem. Here's how I want you to start getting used to it. I want you to see average velocity and know that you need the change in the function above. So to get to the function above velocity, that tells me I've got to integrate velocity. And in this case, 2 to 8. So it's got to be 2 to 8 over 8 minus 2. So this right here could have been one of my answers, but it's not. The other thing is, I know that this right here is going to turn into, if I integrate the top, if I integrate velocity, I know I'm getting position. And then I've got 8 to 2. If I plug in the 8, and then plug in the 2, and then I have the 8 minus 2 on the bottom, that gives me what I'm looking for. So average velocity or average whatever, integrate it over this. And then realize if I integrate this, what would I have? One of these two answers is going to be here. They will never both be there. So there's a couple different ways of looking at that problem. Okay, number 6 is similar to one we did a while ago. I'm interested in 0 to 3. I've got part of it that's F and part of it's that's G. So I'm going to go ahead and do the G part first. The G part over here, 3 to 0 of G is -7. I want 0 to 3 though, so that means instead of -7, it's going to equal 7. But I've also got that right there, that -3, so that means the right part is 21. So I know this right here is -21. So now I need the other piece, 0 to 3 of F. I've got 0 to 6. I've got 3 to 6. So I definitely have to start with the 0 since I start with the 0 here. Since there's a 6 here, that means I've got to have a 6 there. Here, I've got it backwards, so that means I need to switch that and I get a 3. So 0 to 6 is 9, so that means this is 9. 3 to 6 is 5, so that means this is going to be -5 since these two are backwards. 9 minus 5 gives me 4. Don't forget about the 1/2. So 4 times 1/2 gives me 2. 2 minus the 21 gives me the -19. Next one. This is the one we did in class, but we'll run through it real quick again. Okay, again, we are wanting to find average temperature. So average temperature means I need to integrate temperature. Okay, they're telling me my temperature is F, so I want to integrate F. And we're going from 0 to 10. Since I'm doing average, don't forget about the 10 minus the 0 on the box. Okay, and again, you can use your units to figure out whether or not you're doing it correctly. And this is where we want to plug it in our calculator. So again, to get the integral, remember that is shift and plus. Shift and plus gives me this. Then all I have to do is go fill it out. Put 0 in, put 10 in, put the function in, and then put x in. When I do all that, I get 148 and some change. So that means my answer is going to be 149. All right, 8. Continuous function values, we want a left Riemann sum. 0 to 25, 25 to 30, 30 to 50. So 0 to 25 is 25. Left Riemann sum, so I choose the left, which is 4. Next section is 25 to 30, so that's 5. Left would be 6. Last section is 30 to 50, so that's 20. The left would be 8. So we end up with 100 plus 30 plus 160, and we get 290 out of it. And the next one is one of the ones you guys you keep having issues with. Okay, and I really didn't give you enough room to do it in your assignment. I need to adjust that. So I'm going to bring it over here and do it on the whiteboard. All right. So integral from -5 to 1, absolute value 5 plus 2x dx. So to get started, I set the inside equal to 0. And when I solve, I get -5 over 2. So my first integral has to start with this. So -5 to my x value. Leave some space. My second integral has to start with this and end with that. And I'm going to leave myself some space. Then I need to figure out which one goes where. I'm going to choose this one because 0 is located in between there, and 0 is the easiest thing to plug in. If I plug in 0, this produces a positive number, so that means 5 plus 2x has to go there. And that means the opposite has to go over here. Now make sure you change both signs. Both signs have to change. Okay, a couple of us, when we were working on it, didn't change both signs. Make sure you change both signs. Alright, and then I just work each of these separately and then add them together. So -5x minus x squared, -5 to -5 halves. Plug in the -5 halves. 25 over, that one's 2. Minus 25 over 4. Plug in the -5, so that's going to be 25 minus 25. So that's going to go to 0. Common denominator here, that's going to turn into 50, so we get 25 over 4. So I get 25 over 4 out of that piece. Now I need to go figure out that piece. Integrate 5x plus x squared negative 5 over 2 to 1. Plug in 1. 5 plus 1, and then plug in negative 5 halves. So plug in here, negative 25 over 2. Plug in here. Gives me that. So out of this, I get 6. Out of this, multiply 2 over here. So that would be negative 50. So that makes it a negative 25. That's going to make it a positive 25 over 4. So 25 over 4, 25 over 4 gives me 50 over 4 plus 6. 50 over 4 is the same thing as 25 over 2, which is the same thing as 12.5. So best looking answer would be 18.5. So there's that problem. Alright, let's come back over here. Solve the differential equation. So separate. Integrate. So I integrate 1 over here. I get y. Changes to 4. Divide by 4 gives me 3. Changes to 3. Divide by 3 just gives me x cubed minus 7x. Don't forget your or your constant. Plug in negative 6 and 1. Negative 6 equals 3 plus 1 minus 7 plus c. So this would be 4, and negative 7 is a negative 3. Added over gives me a negative 3, so that means c is negative 3. So that means my answer is y equals 3x to the 4th plus x cubed minus 7x minus 3. Next one. Alright, water is pumped into a tank at a rate modeled by W of T liters per hour for 0 to 8, where T is measured in hours. Water is removed from the tank at a modeled by R of T. So WT, water's going in, R of T, water's going out. Where R is differentiable and decreasing on 0 to 8. Selected values of R of T are shown in the table. At time T equals 0, there are 50,000 liters of water in the tank. Alright, first thing we want to do is estimate R prime of 2. Here's R. I need to estimate R prime of 2, so this takes me back to what we were doing on the last test. This is an IROC. To estimate an IROC, I need a ROC. 2 is in here, so that means I need to do 950 minus 1190 over 3 minus 1. And when we work that out, we end up with negative 120. Now make sure you get your units correct. My units of R are liters per hour. I was doing the derivative of it, so that means I'm interested in liters per hour squared. So my units there should be liters per hour squared. So there's my estimate for R prime of 2. Alright, then we want to use a right-Riemann sum with 4 subintervals. Estimate the total amount of water removed from the tank during 8 hours. And then is it an overestimate or underestimate, and give a reason for your answer. So right-Riemann sum. So I'm going 0 to 1, 1 to 3, 3 to 6, 6 to 8. So my first one is 1, and a right-Riemann sum, I use 1190. From 1 to 3, we're dealing with 2. A right is going to use 950. 3 to 6 is 3. A right is going to use 740. And 6 to 8 is 2. A right is going to use 700. So if I do all that, I got 6,710 liters. Okay, and I know it's liters because if I'm doing a right Riemann sum, that means I'm integrating. And if I'm integrating R of t, then that means I'm multiplying my units. So if I multiply liters per hour times the hours cancel, I end up with liters. Now, is it an overestimate or underestimate? Two things tell me whether or not it's an over or an under. First thing is my function increasing or decreasing? And if you look back up, that means it's decreasing. So that means my function is decreasing. Second thing is it a right or left Riemann sum? In this case, it's a right. So that means whenever I draw my rectangles, I'm always going up on the right side. So if I go up on the right side, I get a rectangle there. Up on the right side, and so on. So if you notice, each of these rectangles is underneath. Since it's underneath, that means it's an underestimate. To justify your answer, you're going to do two things. You're going to say because R of t is decreasing and a right Riemann sum was used. So because R of t is decreasing and a right Riemann sum was used. So that's how you determine that. Okay? Whether or not it's decreasing or increasing, and then draw your rectangles. That tells you rectangles below means we are under, rectangles over means we are an overestimate. All right, last one, number 12. All right, so 0 to 3, 0 to 3. So I want to figure this out. I know this right here is going to be a negative 1/2. It's a triangle that's a 1 by 1. So 1 times 1/2 gives me 1/2. And below it, the x-axis, negative. This triangle, 1, 2, 1, 2, it's a 2 by 2. So 2 times 1/2 gives me 2. So that section is 2. Put those two together, we get 0 to 3 is 1.5. All right, now we're doing 3 to 7. So 3 to 7 is made up of two different figures. I've got a rectangle, and then I've got a semicircle. So the rectangle is pretty easy. 1, 2, 3, 4, and 1, 2. So 4 times 2, that means the area of my rectangle is 8. Semicircle, that's going to be 1/2 pi r squared. My radius is 2, so it's going to be 1/2 pi. 2 squared is 4. So I end up with 2 pi. So this top piece is 2 pi. So all of that together is 8 plus 2 pi. All right. My next one is 1 to 9. So 1 to 9. 1 to 9 is what I'm doing next. So I already know that that's 2. I already know this is 8 plus 2 pi. Okay? And then I should notice that these two triangles are the same and they cancel each other out. So that means 1 to 9 is going to be the same thing as 1 to 7. So I have this in the middle plus that. So that means I'm looking at 10 plus 2 pi for 1 to 9. All right, 0 to 9. So 0 to 9, the only thing different between 0 to 9 and 1 to 9 is this little piece right here. So this is negative 1/2. So I just need negative 1/2 on that. So that just makes it 9.5 plus 2 pi. Absolute value takes everything that's underneath and makes it positive. So I'm going to have a positive 1/2, a positive 2, and 8 plus 2 pi. I haven't figured up these two yet. This is a 1 by 2 triangle. So 1 times 2 times 1/2 is going to make it 1, and that means that is also 1. So 2 plus 8 is 10, plus another 2 is 12, plus 1 plus a half makes it 12.5 plus the 2 pi. And the last one, I separate it into two different ones. I already know what 0 to 9 is. 0 to 9 I said was 9.5 plus 2 pi. And then I just need to figure out what 3 is, which is going to be easy. 0 to 9 is 9, and then 9 times 3 gives me 27. So minus 27. So that means I end up with 17.5 plus 2 pi. So there are all your answers to review for quiz 11. I will be available in the library in the morning if you need to come in for extra help. We will see you on Friday.